Welcome, everyone. Today, we are kicking off a multi-day workshop on Git and GitHub. Whether you are just starting out as a developer or you are preparing to work in a real company environment, understanding Git and GitHub is absolutely essential. Over the course of this workshop, we are going to cover what Git is, how it works, why we need it, and how GitHub fits into the picture. We will also look at real-world problems that developers face and how Git helps solve them. So, let's get started. Let's start by laying out what this workshop is going to cover. First, we will answer the most fundamental question: what is Git and why do we even need it? Then we will look at how Git actually works under the hood and how GitHub connects to that. We will explore the advantages of using Git, especially when working in a team. We will also talk about the kinds of problems that come up in a real company setting and how Git helps us handle them. And finally, we will walk through the commit process step by step. There's a lot to cover, so let's dive right in. So what exactly is Git? Git is a distributed version control system, often abbreviated as DVCS. Now, to understand what that means, let's compare it to the older approach, which is centralized version control. In a centralized system, there is one central server that holds all the code, and every developer connects to that single server to get their work done. If that server goes down, nobody can work. But Git is different. In a distributed system, every developer has a complete copy of the entire project history on their own computer. This is a game changer, and we will see exactly why as we go through the advantages. Before we talk about the advantages, let's think about why we need Git in the first place. Imagine you are building a project, maybe a Python web application or a full-stack system, and at some point you make a mistake, a big one. How do you go back to the version that was working? Or imagine your computer suddenly crashes and dies. Where is all your code? What if you are working with a team of 5 developers and everyone is editing the same files? How do you manage that without overwriting each other's work? And how do you keep track of who changed what and when? These are real, everyday problems that developers face, and Git is specifically designed to solve every single one of them. The first major advantage of Git is the ability to go back in time, or more precisely, to roll back to any previous version of your project. Let's say you are developing a feature, and somewhere along the way you introduce a bug or make a mistake that breaks everything. With Git, you do not need to panic. Every time you save a snapshot of your work, which we call a commit, Git remembers it, so you can simply go back to the version that was working perfectly, just like rewinding a video. This is one of the most powerful features Git offers, and it gives developers a huge safety net. The second advantage is that Git works completely offline. Because Git is a distributed version control system, you have the entire project history right there on your own computer. You do not need an internet connection to commit your changes, view history, or switch between versions. You can work on a train, in a remote area, or anywhere without Wi-Fi. When you are ready and you have internet access again, you can sync your work with the team. This is a huge advantage over older centralized systems, where you needed to be connected to the server to do almost anything. The third advantage is seamless team collaboration. In a real company, you are never working alone. You might have 5, 10, or even hundreds of developers all working on the same project at the same time. Git makes this possible. Each developer works on their own copy of the project, and Git provides tools to merge everyone's changes together in a controlled and organized way. You can see what your teammates changed, combine your work with theirs, and resolve any conflicts that come up. This is absolutely essential for professional software development. The fourth advantage is complete change tracking. Git keeps a detailed history of every single change ever made to your project. This includes what was changed, who made the change, and exactly when it happened. This is called the commit history, and it is incredibly powerful. If a bug appears in production, you can look back through the history and pinpoint exactly which change introduced it. You can also see how the project evolved over time. This level of transparency and accountability is something that professional teams rely on every single day. The fifth and final major advantage we will cover is safe backup. Because every developer has a complete copy of the project on their own machine, the code is never truly lost. Imagine your computer breaks down completely. In a centralized system, if the server goes down, everyone is stuck. But with Git, Ram has a copy, Hari has a copy, and every other developer on the team has a copy. So even if your machine fails, the project is safe. This distributed nature of Git acts as a natural automatic backup system, no extra effort required. Now, a very common point of confusion, especially for beginners, is the difference between Git and GitHub. They sound similar, but they are actually two very different things. Git is a tool that you install on your own computer. It is what tracks your changes, manages your history, and lets you work offline. GitHub, on the other hand, is an online platform, a website where you can host your Git repositories. Think of GitHub as the online home for your projects. It is a server where you push your local work so that your team can access it, and so that your code is safely stored in the cloud. Git is the engine. GitHub is the garage where you park it. So what exactly is GitHub? Simply put, GitHub is an online space, a server, where you can store and share your projects. Whatever you are building locally on your computer, whether it is a Python project, a Django web application, a React front-end, or anything else, you can push that project up to GitHub. Once it is there, your teammates can access it, download it, contribute to it, and collaborate with you in real time. GitHub is the bridge between your local work and the rest of your team. It is one of the most widely used platforms in the software development world today. Now, let's talk about the commit process. This is the core workflow of Git. There are 4 stages to understand. First, you have your working directory. This is simply where your files live on your computer and where you make your edits. Second, there is the staging area. When you run the command git add, you are selecting which changes you want to include in your next save. Third, there is the local repository. When you run git commit, you are permanently saving a snapshot of those stage changes into your local Git history. And fourth, there is the remote repository on GitHub. When you run git push, you are sending your committed changes up to GitHub so your team can see them. A helpful way to think about the commit is like loading cargo onto an airplane. Your changes are the cargo, the airplane is the commit. It picks up everything you've staged and locks it in. Once you commit, those changes are safely stored inside your local Git repository, just like cargo that has been loaded and secured in the plane. The command you use is git commit, followed by the -m flag, which lets you write a short message describing what you changed. This message is important because it becomes part of your history log, helping you and your teammates understand what each commit was about. There is one more important concept in the commit process, the .gitignore file. Not every file in your project should be tracked by Git. For example, large image folders, secret configuration files, or automatically generated files do not need to be committed. The .gitignore file is a special file where you list the names of files and folders that Git should completely ignore. In the example shown here, the images folder is listed in .gitignore, which means Git will never include it in any commit. This keeps your repository clean and avoids storing unnecessary or sensitive data. After you have committed your changes, you can check the current state of your repository using the git status command. When you run this command, Git tells you which branch you are on, in this case, the master branch, and whether there are any uncommitted changes. If you see the message, nothing to commit, working tree clean, that means everything is perfectly saved. All your changes have been committed and your working directory is clean. This is a command you will use constantly as a developer to keep track of where you are in your workflow. We will talk more about branches, like the master branch, in the next part of this workshop. So, continuing from where we left off, let's talk about why Git is something every developer genuinely needs. The key point here is that Git isn't tied to any one language or framework. Whether you're working with Python, Java, C++, Laravel, the MERN stack, or anything else, if you're writing code, you need Git. It doesn't matter what you're building or what technology stack you're using. Git is the foundation that sits underneath all of it. Now, think about what happens when you go work at a company. You're not coding alone. You might have a teammate sitting in Dhahran, another in Kathmandu, and a third in Pokhara, all working on the same project. The big question becomes, how do they share files? How do they avoid overwriting each other's work? What happens when 2 people change the same file at the same time? These are real problems that come up every single day in professional environments, and Git is specifically designed to solve them. So this brings us to GitHub. GitHub is essentially an online space, a server on the internet, where you can store your projects. Think of it this way. All 3 developers, one in Dhahran, one in Kathmandu, one in Pokhara, they each build their part of the project locally on their own computers. But to share that work with each other, they all push it up to GitHub. GitHub acts as the central meeting point. And the great thing is, GitHub is available for free. Here's an important distinction to understand. GitHub is not required for everything. If you're working alone on your local machine, writing code, committing changes, tracking your history, you don't need GitHub at all. Git works perfectly fine offline. GitHub only becomes necessary when you need to share your work with someone else, or when you want a backup of your project on the internet. So don't think of GitHub as something you always need running. It comes into play specifically when collaboration or remote access is the goal. So what are the main advantages of using GitHub? First, backup. If your laptop crashes or gets lost, your code is safe on GitHub. You haven't lost anything. Second, team collaboration. Multiple developers can contribute to the same codebase without stepping on each other's toes. And third, access from anywhere. You can pull your project down onto any machine and pick up right where you left off. These three benefits alone make GitHub an indispensable tool in any professional development workflow. Now let's look at the git status command. When you run git status in your terminal, Git tells you the current state of your repository. In this example, the output says you're on the master branch, and there's nothing to commit. Everything is clean. That means all your files are tracked and all your changes have been committed. There's nothing sitting in a pending or untracked state. The branch concept, what master or main means, will be covered in the next session, so don't worry about that just yet. Once you've made several commits, you'll want to look back at your history. That's what git log is for. When you run git log, Git shows you a full list of every commit you've made in reverse chronological order, meaning the most recent commit appears at the top. For each commit, you can see the commit hash, a unique ID, the author's name, the exact date and time the commit was made, and the commit message. You'll also notice the time zone offset, like +0545, which is Nepal Standard Time. This is a complete audit trail of everything that's happened in your project. The way git log orders commits is based on a stack structure. Think of it like stacking bricks. You place the first brick down, that's your first commit. Then you place a second brick on top of it, then a third. The last brick you placed is sitting right at the top of the pile. Git log works exactly the same way. The most recent commit you made appears at the very top of the list. So when you're reading git log output, you're reading from newest to oldest, top to bottom. You'll notice that at the start of each commit entry in git log, there's a long string of letters and numbers. This is called the commit ID or commit hash. Every single commit in Git gets its own unique ID. No two commits will ever have the same one. This ID is incredibly important because it's how you reference a specific point in your project's history. Later on, when we cover things like reverting changes or comparing versions, we'll use these commit IDs directly, so it's worth understanding what they are from the start. Now, the full git log output can get quite long and hard to read quickly, especially when you have many commits. There's a handy shortcut for this: git log followed by 2 dashes and the word online. When you run git log-online, you get the same commit history but compressed into a single line per commit, just the short commit ID and the commit message. It's much easier to scan through. This is especially useful when you just want a quick overview of what's been done in the project without wading through all the details. One important clarification that often comes up: git log is stored locally. It reads from the .git folder on your own machine. You do not need GitHub or an internet connection to view your commit history. And here's another reassurance. Even if you close VS Code or restart your computer, your commit history doesn't disappear. It's permanently saved inside the .git folder in your project directory. The log persists as long as that folder exists. So you never have to worry about losing your history just by closing your editor. Now, let's introduce the concept of git reset. This is where things get a little more serious. Git reset is a command that lets you go back to a previous commit, essentially undoing work. But it's flagged as a dangerous operation because depending on how you use it, you can permanently lose changes. The important thing to know right now is that git reset comes in 3 different types, and each one behaves differently in terms of what it does to your files and your commit history. We'll be going into each of those 3 types in detail very soon. Now, one of the most important things to understand right from the start is that Git and GitHub are 2 completely different things. They sound almost identical, but they serve very different purposes. Git is software. It's a tool, a set of commands that you install on your own computer. It works locally, meaning it runs on your machine without needing the internet. GitHub, on the other hand, is an online platform, a remote server where you can host your projects. Think of Git as your local workspace and GitHub as the internet home for your project. You absolutely do not need GitHub to use Git. GitHub only becomes necessary when you want to share your code with others or back it up online. Here's a great analogy to understand what GitHub actually does. Imagine you're building a website. You build it on your own computer, your local machine. At this point, only you can see it, or maybe people on your local network. But if you want the whole world to see it, you need to host it on the internet, right? That's exactly what GitHub does for your code. When you push your project to GitHub, it goes onto the internet. Your code is now accessible from anywhere in the world. GitHub is essentially a hosting service for your code projects, just like a web host is for websites. So why does GitHub matter? There are 4 major advantages. First, backup. If your laptop dies, gets stolen, or is damaged, your code is safely stored on GitHub's online servers. You never lose your work. Second, collaboration. If you're working with a team, say one person is in Kathmandu and another is in Viratnagar, they can't just share code locally. GitHub gives everyone access to the same code base from anywhere in the world. Third, portfolio. This is huge for your career. You can make your projects public on GitHub, and that becomes your professional portfolio. And fourth, open source and free hosting. When your code is public on GitHub, anyone can view it, contribute to it, and you can even host static websites directly from GitHub for free. Let's talk about why the portfolio aspect of GitHub is so powerful, especially for students. When you graduate and go job hunting, you'll often see requirements like minimum 5 years of experience. That's discouraging when you just finished your exams yesterday. But here's the thing. If you've been building real projects and pushing them to GitHub, you have something concrete to show. You can tell an employer, I know I don't have 5 years of experience, but here's my GitHub link. These are the projects I've built, and these are the skills you're looking for. Please take a look. A company that needs a website built in 3 months cares more about whether you can actually do the work than whether you have a degree. Your GitHub profile is proof of your skills. Build good projects, make them public, and let your work speak for itself. Before you can use Git, you need to make sure it's installed on your computer. Open your terminal. On Windows, that's the command prompt or git bash. On Mac or Linux, it's the terminal. Type the command git space -- version. If Git is installed, you'll see a version number, like Git version 2.50.1. If you see an error or nothing happens, Git is not installed yet, and you'll need to download it. To install Git, open your browser and search for Download Git, or go directly to git-scm.com. You'll see download options for Windows, Mac, and Linux. Choose whichever matches your operating system and install it. One interesting thing worth noting about Git, it's incredibly stable software. Unlike many other tools where old features get deprecated and removed, Git commands from 10 years ago still work perfectly today. The developers have been very careful about maintaining backward compatibility. Once you've installed Git, verify it by running that version command we just saw. For Windows users, when you install Git, it also installs something called Git Bash. Git Bash is a Linux-style terminal that runs on Windows. It's highly recommended to use Git Bash instead of the regular command prompt, because Git Bash gives you Linux-style commands which work much more smoothly with Git. You'll find Git Bash in your Start menu after installation. Just search for Git Bash and open it. It looks like a terminal with a $ prompt. Now let's get into the key terminology you need to know in Git. The first and most important term is repository, often shortened to repo. A repository is simply Git's name for a folder. Just like we normally call a folder a folder or a directory, in Git's world, that same concept is called a repository. It's the folder where your project lives and where Git tracks all your changes. There are 2 types, a local repository, which is on your own computer, and a remote repository, which is on GitHub, online. Keep this distinction in mind as we move forward. Here is the most important concept in Git, and the instructor uses a brilliant analogy to explain it. Think about going to an airport. First, you're at the airport. That's your working directory, your project folder where you do all your work. From the airport, you go to the waiting room. That's the staging area, where you prepare the files you want to commit. From the waiting room, you board the airplane. That's the local repository, where your committed changes are stored. And eventually, the airplane flies to a destination like the USA. That's the remote repository on GitHub. This 3-stage flow, working directory, staging area, repository, is the heart of how Git works. Understand this, and you understand Git. To start using Git in a project, you run the command git init inside your project folder. This command initializes a new Git repository. When you run it, Git creates a hidden folder called .git inside your project. You won't normally see this folder because it's hidden, but it's there and it's critically important. It's what makes your folder a Git repository. Think of running git init as building the airport. Once you've done that, your working directory is active and Git is ready to track your files. Never delete or manually edit the .git folder. That would break your repository. The command git status is your way of asking Git, what's going on right now? Before you run git init, if you type git status, Git will tell you this is not a Git repository because you haven't set one up yet. But after running git init, git status gives you useful information, which branch you're on, whether you have any commits, and which files are untracked. Untracked files are shown with a U symbol. These are files Git can see in your folder, but it's not tracking their changes yet. They're like people at the airport who haven't checked in yet. Once you have files in your working directory, you need to move them to the staging area before you can commit them. This is the git add command. It's like putting passengers into the waiting room before they board the plane. You can add a single file by typing git add followed by the file name. You can add multiple specific files by listing them separated by spaces. Or you can add everything at once using git add dot. However, the best practice is to add files by name rather than using the dot shortcut. Why? Because using dot adds everything, including files you might not want to commit, like temporary files or sensitive configuration files. Be intentional about what you stage. After staging your files, the next step is to commit them. This is like boarding the airplane. The command is git commit -m followed by your message in quotes. The -m flag is mandatory. You cannot commit without it. The message is what describes what you did in this commit. Now, there are important rules for writing commit messages. Always write in the present tense. Say add hero section, not added hero section. Keep it short and clear. And be specific. Mention what you actually changed. For example, add hero section in index.html. Good commit messages make it easy to understand the history of your project later, especially when working in a team. One of the core rules of Git is the concept of atomic commits. Atomic means one unit, one logical piece of work per commit. For example, if you're building a web page, you don't wait until the entire website is done and then make one giant commit. Instead, you commit after finishing each meaningful piece. One commit for the navigation bar, one for the hero section, one for the services section, and so on. Why does this matter? Because if something breaks later, you can pinpoint exactly when and where the problem was introduced. You can also revert a specific change without losing everything else. Think of each commit as a save point in a video game. The more save points you have, the less progress you lose if something goes wrong. Before you start making commits, there is an important one-time setup you need to do: configuring your identity in Git. You need to tell Git your name and email address. Use the commands git config-global user.name followed by your name in quotes, and git config-global user.email followed by your email in quotes. Why is this necessary? When you're working in a team, say Ram, Sham, and Hari are all working on the same project, Git needs to know who made which commit. If a bug appears, you need to be able to trace it back to the person who introduced it. Your name and email get attached to every commit you make. This is a one-time setup. You only need to do it once per computer. Now let's talk about resetting in Git. This is a dangerous area, so pay close attention. There are 3 types of reset: soft, mixed, and hard. A soft reset undoes your last commit, but keeps your files in the staging area, the waiting room. It's like taking passengers off the airplane and putting them back in the waiting room. A mixed reset, which is the default, undoes the commit and removes files from staging. They go all the way back to the working directory, untracked. And a hard reset, this is the dangerous one. It undoes the commit and deletes all the changes. Those files are gone. They cannot be recovered. Think of it as kicking passengers out of the airport entirely. The instructor is very clear. Never use hard reset unless you absolutely know what you're doing. You've seen the term head in the reset commands. Let's understand what it means. Head is simply a pointer to your most recent commit on the branch you're currently working on. If you're on the master branch and you've made 3 commits, head points to commit number 3, the latest one. When you write head-1, that means one commit before head. In other words, the previous commit. So when you run git reset head-1, you're saying go back one commit from where I currently am. You can check which branch you're on by running git branch. The branch with an asterisk is your current branch. Let's compare soft and mixed resets more clearly. With a soft reset, your commit is undone, but your files land back in the staging area. They're still ready to be committed again. You'll see them marked with A for added, meaning they're staged. With a mixed reset, which is the default when you don't specify a type, your commit is undone and your files are moved back to the working directory as untracked files. You'll see them marked with U. In both cases, your actual code changes are safe. Nothing is deleted. The difference is just where in the workflow your files end up. Both are recoverable situations. You can restage and recommit whenever you're ready. Hard reset is the most dangerous Git command you'll encounter. When you run git reset-hard head-1, Git doesn't just undo your commit. It completely deletes all your uncommitted changes. Imagine you spent an entire day writing code, making improvements, fixing bugs. One wrong command, and all of that is gone. Permanently. There is no undo. The instructor is very direct about this. Do not use hard reset. It exists, but treat it like a button you never press. If you need to undo changes safely, use git revert instead, which we'll cover next. The only scenario where hard reset might be used is if you intentionally want to throw away all local changes. But even then, be absolutely certain before running it. The getDiff command is incredibly useful when you've been working for a while and want to see exactly what changed since your last commit. Run getDiff followed by your branch name. For example, getDiff master. Get will show you a comparison. Lines in green with a plus sign are newly added content, and lines in red with a minus sign are content that was removed or changed. This is perfect for those moments when you step away from your code, come back after lunch, and can't remember what you were working on. Instead of guessing, just run getDiff, and Git tells you precisely what's different. It's a great habit to run this before staging your files. Git revert is the safe alternative to hard reset when you need to undo changes. Here's the key difference. Reset removes commits from your history, while revert creates a brand new commit that undoes the previous one. Your history stays intact. This is important because in a team environment, you want to be able to see the full story of what happened, who added something, who removed it, and why. With revert, that story is preserved. To use it, first run git log tosh online to see your commit history and find the commit ID you want to undo. Then run git revert followed by that commit ID. Git will create a new commit labeled something like revert hero section. Your code goes back, but the history shows exactly what happened. To summarize the difference between revert and reset, revert is the professional, team-friendly way to undo changes. It preserves your commit history, which means anyone looking at the project later can see the full story, what was added, what was reverted, and when. Reset, especially hard reset, is destructive. It removes commits from history and can permanently delete your work. In a team setting, if you push a hard reset to a shared repository, you could overwrite your teammates' work too, which is a serious problem. The rule of thumb is simple. Use revert when you need to undo something. Avoid reset unless you have a very specific reason and you fully understand the consequences. Sometimes you'll add a file to the staging area and then realize you don't want to commit it yet. Maybe you staged the wrong file, or you want to make more changes first. The command git restore staged, followed by the file name, lets you unstage a file. It moves it back from the staging area to the working directory. Importantly, this does not delete your changes. Your code is completely safe. The file just moves back to the airport, so to speak, from the waiting room. You can then make more edits and restage it when you're ready. This is a safe, reversible operation. No data is lost. Let's bring everything together with a complete picture of the Git workflow. You start in your working directory. This is where you write and edit your code. Files here are untracked. When you're ready to save a logical unit of work, you use git add to move files to the staging area. From the staging area, you use git commit-m with a message to permanently save that snapshot to your local repository. The key commands to remember are git init to create a repository, git status to check what's happening, git add to stage files, git commit to save them, git diff to see what changed, git log to view your commit history, and git revert to safely undo changes. The remote repository on GitHub, where you push your code to the internet, that's coming up in day 3. Let's start by making sure the distinction between Git and GitHub is crystal clear, because these two terms are often confused. Git is a software. It's a program you install on your own computer, and it's where you run commands to track changes in your code. GitHub, on the other hand, is simply an online place to store your projects. Think of it as a server or a cloud storage platform. The projects you build on your local computer get pushed up to GitHub so they're saved remotely and can be shared or collaborated on. So Git is the tool, GitHub is the hosting platform, two different things working together. Now, why do we even need to configure Git? Imagine you're working in a team of 3 developers, all pushing code to the same project. If something breaks, and things do break, you need to be able to trace back who made which change. Git needs to know your identity so it can attach your name to every commit you make. This is why right after installing Git, the very first thing you should do is configure it with your name and email. It's not just a formality, it's essential for accountability in any collaborative project. To see what your current Git configuration looks like, you run the command git config --list in the terminal. This lists out all your current settings. In this example, the username is set to Sajal Shrestha, and the email is set to codeddem.np@gmail.com. These two pieces of information, your name and your email, are what Git uses to label every single commit you make. If you've never set these up, Git won't know who you are, and your commits won't be properly attributed. To set your identity in Git, you use two commands. First, git config-global user.name, followed by your full name in quotes. Second, git config-global user.email, followed by your email address. The -global flag is important. It means these settings apply to every repository on your computer, so you only need to do this once. Use your real name and the email address linked to your GitHub account. And don't worry, if you ever need to change these later, you can simply run the same commands with updated values and they'll be overwritten. When you initialize a Git repository, Git creates a hidden folder called .git inside your project. This folder is where Git stores all of its tracking data, every commit, every change, every piece of history. By default, this folder is hidden, which is why you don't normally see it in your file explorer. To make it visible in VS Code, you can go into the settings, open the settings.json file, and adjust the files.exclude setting for .git. Setting it to false makes the folder visible. But here's the thing, you don't actually need to see it to work with Git. It's hidden for a reason, and most of the time you'll just leave it hidden. The instructor is showing it here purely so you can understand what's happening behind the scenes. The command git init is how you create a new Git repository. Think of it this way. When you want to create a regular folder on your computer, you right-click and select New Folder. That creates a brand new empty folder. Git init does the same thing, but in the Git world. It creates a brand new Git tracked folder, which is called a repository. When you run git init, Git responds with initialized empty Git repository. And yes, it's empty at first. That's completely normal. Nothing is in it yet. A repository is simply a folder that Git is now watching and tracking. That's all it is. Before diving deeper, let's look at the big picture of the Git workflow. You have 4 stages. First, your working directory. This is where you write your code. Second, the staging area, also called the index. This is like a waiting room where you place files that are ready to be committed. Third, your local repository. Once you commit, the snapshot is saved in your local Git history. And fourth, the remote repository on GitHub, where you push your work so it's stored online. The commands that move things between these stages are git add, git commit, and git push. The instructor has covered git init, git add, and git commit so far, and next up is git ignore. Now let's talk about git ignore, and this is actually a very important concept. As your projects grow, you'll have files and folders that you don't want Git to track. For example, the Node modules folder in a JavaScript project can be enormous, thousands of files, and there's no reason to push all of that to GitHub, because anyone can regenerate it. Similarly, you might have a .env file containing passwords or API keys that should never be made public. The .gitignore file is where you list all the files and folders you want Git to completely ignore. Git will not track them, not stage them, and not commit them. It's a simple but critical tool for keeping your repositories clean and secure. Now, let's connect Git commits to a concept called atomic design, and this is where things get really practical. Atomic design is a philosophy for building user interfaces, where you break everything down into the smallest possible units. Imagine you're building a website's navigation bar. Instead of building the entire nav bar all at once, you break it into components. One component for the logo, one for the search bar, and one for the menu items. Each of these is a small, focused, independent unit. When you combine them, you get the full navigation bar. This is exactly why React encourages component-based thinking. It makes building, testing, and maintaining UI much easier. And this concept directly influences how you should be making your Git commits. The atomic design concept applies directly to how you should structure your Git commits. The rule is simple. Complete one unit of work, then commit. Don't commit half-finished work, and don't mix multiple unrelated changes into a single commit. For example, if you're building a school website, you might work on the hero section first. Once that's fully done, you commit with a message like add hero section on homepage. Then you move on to the message from principal section. Once that's complete, the heading, the paragraph, the photo, you commit again with a clear message. Each commit represents one complete, meaningful unit of work. This makes your history clean, readable, and easy to navigate if something goes wrong later. Here's a real-world example. The instructor walks through. You're building a message from principal section. You write the heading, then you get called for lunch. You save the file, but you don't commit yet because the section isn't done. You come back, write the paragraph. It takes a while to think through, maybe 2 hours, and then you fall asleep. Still no commit because the section isn't finished. You wake up, add the principal's photo using a placeholder image from Lauren Pixham, and now the section is complete. Only at this point do you stage the file with git add and commit with a message like add message from principal on index page. The key insight is that saving your file and committing to Git are two completely different things. You save constantly, but you commit only when a meaningful unit of work is fully done. The instructor uses a brilliant analogy to explain the staging area. Think of it like an airport. Your modified files are people standing outside the airport. The staging area is the departure lounge, the waiting room where passengers gather before boarding. And the repository, your commit history, is the airplane. You cannot put someone directly onto the airplane from outside the airport. They must first go through the waiting room. That's exactly how Git works. You cannot commit a file that hasn't been staged first. If you try to run git commit without first writing git add, Git will tell you there's nothing to commit because the file isn't in the staging area yet. So the flow is always modify your file, git add to stage it, then git commit to record it permanently. Once you've made several commits, you can view your entire commit history using git log. Running git log --online gives you a compact single-line view of every commit, showing the short commit ID and the commit message. This is great for a quick overview. If you want even more detail, git ref log shows the full reference log, including every action you've taken in the repository. Each commit has a unique identifier, a hash, that you can use to reference that specific point in time. The head pointer shows you where you currently are in the history. This history is incredibly valuable. If something breaks, you can look back and see exactly what changed, when it changed, and who changed it. That's the whole power of version control. The instructor wraps up by introducing the concept of branches, and this is where Git becomes truly powerful for team collaboration. A branch is essentially a separate version of your project where you can work on new features without touching the stable main version. Think of it like a parallel timeline. Your main branch stays clean and stable, while you create a feature branch to experiment or build something new. Once the feature is complete and tested, you merge it back into the main branch. This is how professional development teams work. Multiple developers work on different branches simultaneously, each on their own feature, without stepping on each other's code. Branches are the next major concept to explore as you continue your Git journey. So let's quickly pick up from where we left off. The instructor makes a very clean distinction here between two things that beginners often confuse, Git and GitHub. Git, in simple terms, is a software tool. It's something that lives on your computer, and you interact with it by typing commands. GitHub, on the other hand, is an online place to store things, essentially a server, where you can push your projects so they're saved online. And the best part? GitHub is free to use. The instructor puts it beautifully. Think of Git as the commands and the software you work with, and GitHub as the online home where your projects live. We're going to focus on Git first, and only look at GitHub later, because you need to understand Git before any of that makes sense. So why do we actually use Git? The instructor asks the class, and a student correctly answers, version control. That's exactly it. Git is primarily used for version control. But what does that actually mean? Imagine you're working on a project. You make changes, add features, fix bugs, and Git keeps a record of every single one of those changes over time. So if something breaks, or you want to go back to an earlier version of your code, you can. It's like having a complete history of your project. The instructor is about to walk through a story to make this really concrete, so let's follow that thinking. All right, so we've already covered git init, git add, and git commit. Now the instructor moves on to something called git ignore, and he emphasizes that this is an extremely important concept. So far, our projects have been simple, but as you grow as a developer and start working on real-world projects like e-commerce platforms, things get more complex. You'll have API keys, payment credentials, server passwords. These are things you absolutely cannot share with anyone. Without gitignore, everything you track and push goes up to GitHub, including those secret files. With gitignore, you get to tell Git, hey, don't track these specific files. They stay on your machine only. That's the power of gitignore. The instructor gives a really practical example here that makes this crystal clear. Imagine you're building an e-commerce project and you need to integrate eSewa, a popular payment gateway. To use their payment system, you have to pay them, say 5,000 rupees, and in return, they give you an API key. Now, that API key is essentially your license to use their service. If you accidentally push that key to GitHub, where it's publicly visible, anyone can grab it and use it for free, and every transaction they make gets charged to your account. Your money drains, and you get nothing in return. This is not a hypothetical. This happens to real developers. So the instructor is making the point that anything sensitive, like API keys, passwords, or server credentials, must never go to GitHub. That's exactly what gitignore is designed to prevent. The instructor then extends this into a team scenario, which is where gitignore becomes even more critical. Imagine a project where 3 developers, A, B, and C, are all working together. Developer A has been assigned the task of integrating the eSewa payment gateway, so the API key is given to developer A. Now, developers B and C don't need that key, and frankly, they shouldn't have access to it. But if developer A pushes everything to Git without using gitignore, the API key ends up on the shared server, and now B and C can see it too. That's a serious security problem. The solution is simple. Developer A adds the API key file to gitignore, so it never leaves their local machine. Only they can use it, and the rest of the team works without ever seeing it. So how do you actually use gitignore? The instructor walks through it step by step. First, you create a new file inside your project folder. The name of this file must be exactly .gitignore. That's a dot, then the word gitignore, all lowercase. This exact name is required. Git specifically looks for a file with this name. You cannot call it something else. Inside this file, you simply write the names of the files or folders you want Git to ignore. Once you save it, Git will stop tracking those listed files entirely. They become invisible to Git, as if they don't exist from Git's perspective. Let's look at the concrete example the instructor uses. Say you have a file called secret.txt in your project. Inside that file, you've stored your API key and your server password. Things like, this is my key, and a password like 123. These are extremely sensitive. Now, this file shows up as untracked in Git, meaning Git has noticed it exists but isn't tracking it yet. The instructor's point is you don't want Git to ever track it. So you open your .gitignore file and simply write the file name, secret.txt. The moment you save that, something interesting happens. The file disappears from Git's view entirely. Git no longer sees it, no longer tracks it, and it will never be pushed to GitHub. It exists only on your machine, for your reference only. So what kinds of things typically go into a gitignore file? The instructor's example focuses on API keys and passwords, but in real projects, there's a whole category of files you'll want to ignore. API keys, server passwords, payment gateway credentials, these are the obvious ones, but there are also things like environment variable files, which are commonly named .env, where developers store all their configuration secrets. In larger projects, you'll also ignore things like the node modules folder, which can contain thousands of files that don't need to be pushed, or build output folders. The general rule the instructor implies is simple. If you wouldn't want your teammates or the public to see it, it goes in gitignore. Now, the instructor shifts to talking about branch management, another core concept in Git. The idea is straightforward. Branches let you work on different versions of your project simultaneously, without affecting the main stable version. Imagine you're working on a project, and suddenly you get an idea. What if I add this feature? Instead of adding it directly to your main code and potentially breaking things, you create a new branch. You experiment there. If you like what you see, you can merge it back. If you don't like it, you simply delete the branch. No harm done to the main project. The instructor even mentions you can have alpha versions, beta versions, all as separate branches. It's a powerful way to manage experimentation and development. The instructor wraps up this section by pointing toward what's coming next, and it's arguably the most important real-world skill you'll need. When you go for an internship or join any company, you'll be working in a team. Multiple developers working on the same codebase, each on their own branch. And here's the thing. Sometimes 2 developers change the same file. When those branches try to merge back together, Git detects a conflict. What do you do then? How do you resolve it? That's the scenario the instructor says will be covered in the next class. It's not just a theoretical problem. It's something every developer faces regularly in professional environments. So branches aren't just about experimentation. They're the foundation of how teams collaborate on code. So let's talk about why we actually use Git in the first place. The instructor here asks the students, why do we need Git? And the answer that comes back is version control. But what does that really mean in practice? Let's think through a story to make this concrete. Imagine you're working on a project. You've built it up nicely. Everything is in place. Then suddenly, an idea pops into your head. What if I added this new feature? It sounds great, but you're not sure if it'll actually work. So what do? Without Git, you're stuck in a really frustrating situation. You might try making a new folder, something like Project Version 2, just to keep things separate. But if you don't do that and you work directly in the same codebase, your original code gets messed up. Now, here's the worst-case scenario. You add the new feature, it doesn't work out, and now you've lost your clean original code and the new feature is broken. You've got nothing good left. That's the core problem that Git solves. It lets you experiment freely without ever losing your previous working state. This is exactly where Git shines. Git is a version control system, meaning it keeps a full history of your project. Every time you save a snapshot, called a commit, Git remembers exactly what your code looked like at that moment. So if you try that risky new feature and it fails, you can simply roll back to your last good snapshot. Your original code is completely safe. The instructor emphasizes this point strongly. Git is primarily used for version control, and that's the most important reason to learn it. Now let's talk about a very important Git concept, the .gitignore file, or just gitignore. When you're working on a project, not every file should be tracked by Git or shared with others. The gitignore file is how you tell Git, hey, ignore these files completely. Don't track them, don't include them in commits. The instructor demonstrates this live. He has a file called secret.x, and the moment he adds its name to the gitignore file and saves, that file disappears from Git's list of untracked files. Git simply stops seeing it. The instructor gives two really practical categories of things you'd put in gitignore. First, sensitive files, things like passwords, API keys, or any secret configuration. You absolutely do not want those pushed to a shared repository where teammates or the public can see them. Second, large files. The classic example here is the Node modules folder in a Node.js project. This folder can easily be 500 megabytes, sometimes even a gigabyte or more on large projects. If you accidentally push that to a remote server, you could crash the server entirely. So the rule is simple. If it's secret or if it's huge, it belongs in gitignore. Here's how gitignore actually works in practice. You open the .gitignore file, it lives in the root of your project. You type in the name of whatever file or folder you want Git to stop tracking. For example, you write secret.env or node_module/. Then you save the file. That's it. The moment you save, Git stops tracking that entry. It vanishes from the untracked files list and will never be included in your commits. The instructor also shows the reverse. If you remove a file's name from gitignore and save again, Git starts tracking it again. It's that straightforward. Here's another subtle but important point the instructor brings up. Sometimes you want to create an empty folder in your project, say an images folder inside an assets directory, because you plan to put files there later. But here's the thing. Git does not track empty folders. If a folder has no files in it, Git simply ignores it. So if you commit your project, that empty folder won't be included. The common workaround is to place a placeholder file inside the folder, conventionally named .gitkeep. It's just an empty file, but its presence means Git now has something to track, so the folder gets included in your commits. Now the instructor shifts to a topic that becomes critically important once you start working professionally: conflict resolution. When you're doing an internship or working at any company, you're working in a team. Multiple developers are editing the same codebase at the same time, and sometimes two people edit the exact same line of the same file. When that happens, Git can't automatically figure out which version to keep. This is called a merge conflict. The instructor is clear that this is something they'll go deep into in the next session, because it's one of the most important real-world Git skills you need. The instructor really stresses why this matters. When you're in a professional environment, whether it's an internship or a full-time role, you are always working in a team. Your code and your colleagues' code are going to collide. Conflicts are not a sign that something went wrong. They're a completely normal part of collaborative development. What matters is knowing what to do when they happen. The instructor promises that the next session will cover exactly that: what a conflict looks like, what happens when it occurs, and most importantly, how to resolve it. Every one of those questions will be answered in depth. Before wrapping up the session, a student asks a quick but genuinely useful question. How do you go back to a command you already typed in the terminal? The instructor's answer is simple. Use the up and down arrow keys. Pressing the up arrow scrolls backward through your command history, showing you each command you've previously run, one at a time. Pressing the down arrow moves you forward again toward the most recent command. This is a small tip, but it saves a huge amount of time. Instead of retyping long Git commands, you just arrow up, find the one you want, and hit enter. It's one of those things that becomes second nature very quickly. Let's think about a very common problem in software development. Imagine you're working on a project and you decide to add a new feature directly to your existing code. You start making changes, and then the feature doesn't work out. Now you're in trouble, because not only did the new feature fail, but you've also messed up your original working code. Both are broken. This is exactly the kind of disaster that version control is designed to prevent. With Git, your original code stays safe in one place, and any experimental work happens in a separate version. If things go wrong, you simply go back to what was working before.
So what exactly is Git? Git is a version control system, a tool that tracks every change you make to your project files over time. It does three really powerful things. First, it lets you create separate versions of your project, so you can experiment freely without touching your main code. Second, it tracks the complete history of your project. Every single change is recorded. And third, it lets you revert to any previous version at any time. Think of it as a time machine for your code.
Let's make this concrete with an example. Say you've built a website and you're happy with the current theme. Now your client says, hey, what would this look like with a pink theme? Instead of changing your original code and risking breaking it, you create a new version, a branch, just for the pink theme. Your original copy stays exactly as it was. Then maybe someone else says, what if the menu looked completely different? You create yet another version from the original for that experiment. Each version is completely independent. You can switch between them, test them, and decide which one to keep, all without ever touching your original working code.
Git is not just about saving versions. It's a complete project management tool. Let's go through what it actually lets you do. You can track your entire project over time, so you always know what changed and when. You can create separate versions to test new ideas without any risk. If a version doesn't work out, you can revert to a previous one instantly. You can test completely different ideas at the same time in parallel. And perhaps most powerfully, you can collaborate. Imagine you're working on a project and someone else comes along and fixes a bug for you. Git makes that kind of teamwork seamless and safe. There's a lot more depth to Git, and we'll go through it step by step.
Before we go deeper into Git, it's worth understanding where the concept of version control came from, and this is actually something that comes up in technical interviews. Before Git, there was something called a centralized version control system, or CVCS. In a centralized system, there is one central server that holds all the versions of the project. Every developer connects to that server to get their files and save their changes. Tools like SVN and CVS worked this way. The big problem? If that central server goes down, nobody can work. Git is different. It's a distributed version control system. Every developer has a complete copy of the entire project on their own machine. There's no single point of failure. This is a key concept to understand, and it's worth remembering for interviews. Now, let's talk about tracking files in Git. Suppose you're building a project and you need an images folder. You go ahead and create a folder called images inside your assets directory. But here's something important. Git does not track empty folders. If a folder has no files in it, Git simply ignores it. You can see this when you check the status. The folder shows up as untracked, meaning Git hasn't registered it at all. This trips up a lot of beginners, so it's good to know up front.
So how do you force Git to track an empty folder? There's a simple and widely used trick. Inside the empty folder, you create a new file and name it .gitkeep, written as .gitkeep. That's it. The moment there is any file inside the folder, Git will start tracking it. The .gitkeep file itself doesn't do anything special. It has no special meaning to Git. It's just a convention that developers use as a placeholder to say, hey Git, please keep track of this folder. Once you add that file, the folder goes from untracked to tracked, and it will be included in your repository.
Now let's understand the different states a file can be in when you're working with Git. And there's a great analogy to help you remember this. Think of your project folder as an airport. When files are untracked or modified, they're just wandering around inside the airport. Git knows they exist, but hasn't done anything with them yet. The staging area is like the waiting room. When you run git add, you're moving files from the airport floor into the waiting room, saying, these are the files I want to save. And the local repository is the final destination. When you run git commit, those files are permanently saved as a snapshot in your project history. The letter U you see next to files in Git means untracked. Those files are still in the airport, not yet in the waiting room.
Before Git came along, the world used what's called Centralized Version Control Systems, or CVCS. The concept is right there in the name. Centralized means there was one main server, and that server held the entire project. Tools like Apache Subversion, also known as SVN, and Perforce were popular examples of this. So imagine you have 3 developers all working on the same project. They all had to connect to that one central server through the network to do anything. And here's the critical limitation. Only one developer could commit or make changes at a time. Everyone had to take turns.
On top of that, these systems were paid. You had to buy a license to use them. Now, here's where the real problem shows up. What happens if that central server gets damaged, shuts down, or simply loses its network connection? Every single developer is completely blocked. Nobody can work. You just have to sit there and wait. This is called a single point of failure. One problem in one place brings the entire team to a halt. And remember, you're also paying for the system. So you're paying for something that, the moment it has a problem, makes your entire team unproductive. This was a serious limitation that the software development world needed to solve. The solution was Distributed Version Control Systems, or DVCS, and Git is the most famous example of this. Here's the key difference. Instead of one central server holding everything, every single developer gets their own complete local copy of the entire project on their own computer. So if you have 3 developers, all 3 of them have a full copy of the project sitting right on their local machines. Now think about what this means. Even if the remote server goes down, even if the internet is completely disconnected, every developer can still keep working independently on their own local copy. This was a revolution. Let's put this side by side so the contrast is crystal clear. With the old centralized systems, there was one server. Only one person could commit at a time. If the server went down, nobody could work, and you had to pay for it. With Git and distributed version control, every developer has their own full copy. Everyone can work at the same time. You can work completely offline on your local machine, and it's free and open source. This is why Git completely took over the industry. Even companies like Microsoft, who had their own centralized version control tools, eventually moved away from them. Git brought a genuine revolution to how software is built. Before we move on, there's an important mindset point worth understanding. Updates and new versions of software don't just appear out of thin air. Think about it. When a website or an application releases a new update, it's because something was identified as a problem or something new was needed. Developers found an issue, worked on a solution, and then released that solution as a new version. This is true for Git itself, and it's true for every piece of software you'll ever work on. Every update represents a problem that was solved or an improvement that was made. Keep this in mind as you build your own projects. Now let's talk about the staging area, and there's a really clever analogy used to explain this. Think of your project folder as an airport. When your files are untracked, they're inside the airport building. They exist, they're there, but they haven't been processed yet. The staging area is like the waiting room or the departure lounge. When you move files into the staging area, they're checked in and ready to board. And the local Git repository, where your commits are permanently saved, that's the airplane. Once you commit, those files are on the plane and the snapshot is locked in. So how do you actually move files into the staging area? You use the command git add. If you type git add followed by a dot, that dot means everything. Specifically, all the untracked files in the current folder get added to the staging area at once. You can also add a single specific file by typing git add followed by the file name. After running git add, if you check git status again, you'll see those files are now shown in green, meaning they're staged. They're in the waiting room, ready to be committed. The dot is a shortcut that's very commonly used when you want to stage everything at once. Once your files are staged, sitting in the waiting room, the next step is to commit them. The command is git commit with a -m flag, followed by your commit message in quotes. The -m stands for message, and it lets you write a short description of what changes you made, right there in the command. For example, git commit -m add git ignore and image folder tells anyone reading the history exactly what this commit was about. Committing is the act of permanently saving a snapshot of your staged files into the local repository, putting them on the airplane, so to speak. The files are now tracked and versioned by Git. Always write meaningful commit messages. Your future self and your teammates will thank you. There's one more important concept here, the .git ignore file. Not everything in your project folder should be tracked by Git. For example, a folder full of large images, or files containing secret API keys, or automatically generated folders like node modules. These don't need to be version controlled. The .git ignore file is a special file where you list everything Git should ignore. In the example shown, the images folder is listed in .git ignore, which means Git will completely skip it. It won't show up as untracked, it won't be staged, and it won't be committed. This keeps your repository clean and focused on the actual code that matters. Let's bring the entire workflow together. Step 1, you create or edit files in your working directory. Step 2, you use git add to move those files into the staging area, the waiting room.
Step 3, you use get commit with a message to permanently save that snapshot into your local repository. And eventually, step 4, you'll push that to a remote repository like GitHub so others can access it. Supporting all of this is git status, which tells you where your files are at any point, and .gitignore, which keeps unwanted files out of the picture entirely. This 4-step flow is the heartbeat of working with Git every single day.
Let's close with the big picture. The journey from centralized to distributed version control is the story of why Git exists. Centralized systems had a fatal flaw. One server going down meant everyone stopped working. Git solved that by giving every developer their own complete copy of the project, making offline work possible and eliminating that single point of failure. Then, within Git itself, the 3-zone model, working directory, staging area, and local repository, gives you precise control over exactly what gets saved and when. You use git add to stage your changes, git commit to lock them in, and .gitignore to keep your repository clean. These are not just commands to memorize. They are the fundamental concepts that everything else in Git builds upon. Master these, and the rest will follow naturally.